This is just a quick review of some integration techniques, and I hope, this is from an old AP exam. I hope you would look at this and right away check substitution. It should be the first thing on your mind. If I made u equal to 2x plus 3, du would be 2dx. This is going to work absolutely wonderfully. So let's make u 2x plus 3. So du will be 2dx. Divide, and then I can rewrite my integral as 1/2 integral of u to the 5th du, or u to the 4th, excuse me, I'm ahead of myself here, u to the 4th. So now we raise the power, it becomes u to the 5th, dividing by the new power, but we already have that 1/2 there, so it's going to be 1/10 plus c. Now we would plug it back in, but I think we can match right away. The answer is going to be D. This one I look at and I think, well, it's kind of pre-factored for me, and that's kind of nice. But if I multiplied it out, I'd have x squared plus x. It's not going to work to do substitution, either one, the old kind or UDU. So I look for integration by partial fractions. So if I have a over x plus 1 plus b over x, it's going to be equal to x plus 3 over x plus 1 multiplied by x. So a multiplied by x plus b multiplied by x plus 1 is equal to x plus 3. We've got to get those coefficients. So we pick the easy ones. X equals 0. Gets rid of a, so we just have 1b equals 3, so that's it. B is equal to 3. The other easy one to pick would be negative 1. Okay, so then we have negative 1a equals 2, so that means that a is equal to negative 2. That. Okay, so we can plug those back up here, negative 2 and 3, that. Rewrite our integrals. Negative 2 over x plus 1 dx plus integral of 3 over x dx. Pull our constant multipliers out front, make it easier on us. Okay, so we're going to have negative 2 times the natural log of x plus 1 plus 3 times the natural log of x plus c. So to me it looks like the answer is C. Be very careful with where you put the coefficients back in. That's a common mistake, is people solve for them and then accidentally put them in the wrong spot. The other thing is, don't just always assume that it's going to be natural log. It works out to be natural log here because the derivative of x plus 1 is 1. If this were 2x plus 1, we'd have to not only do integration by partial fractions, but we'd have to do substitution as well. This last one we look at, and you say, okay, well, would substitution work? If u is equal to negative 3x, du would be negative 3, so it's not going to work. So it's a product. Substitution won't work. We're left with then integration by parts. So we pick our u. I usually pick the part that would terminate. So u is equal to x. Du is equal to dx. If u is x, dv is everything else. So e to the negative 3x dx. The antiderivative, you got to kind of think substitution here in your head. You're going to have negative 1/3 e to the negative 3x. Okay, we do the 7. So we're going to have x negative 1/3 x times e to the negative 3x minus the integral of negative 1/3 e to the negative 3x dx. Well, we could bring that negative 1/3 out front, do that, And actually, the antiderivative of e to the negative 3x is substitution. You know, we can do that. So negative 1/3 x e to the negative 3x stays the same, plus 1/3 multiplied by the antiderivative, which would be negative 1/3 e to the negative 3x, plus c. So of course, multiplying this in, 1/3 times negative 1/3 would be 1/9. So the answer is going to be D.